Hi Rajiv, good evening. Am I audible? Hello. Yeah. Okay. Thanks. So maybe I'll wait 2 3 minutes. 7:05 we can start. Wait for. Yes, Neha. Hello. Yeah. So Rajiv, please mute yourself. Let me see actually. So we can start now. It's 7:05. People will anyway join till the end. So, good evening, everyone. So, this is the third discussion session we'll carry on today. So, today, the thing that we'll discuss about the problem solving that you encountered in the second week of your classes, like mainly the Venn diagram, how to solve different problems or the syllogism problems using this Venn diagram, those, and then we will solve the secondary assignment problems as well. So I think we can start now. Then we have made our presentation, so I don't know whether I can complete it today. But if it's something is will be given that I will discuss later. So then, so the screen is visible, right? Yeah. Okay. Thanks. Okay. So the main thing today, we'll just briefly say some definition that will be required for this discussion. That is syllogism. Syllogism that you have read in the second week, and I think I have told also in the last week. So that is what is syllogism. Syllogism is not. I mean, is a deductive argument in which a conclusion is inferred from two premises. So basically, there are two premises. Based upon that, we have to come to a particular conclusion. So that can be true or false. That we have to see. Now, category. Now, different parts of syllogism. Now, first one is this categorical syllogism, a deductive argument consisting of three categorical propositions that contain exactly three terms, each of which occur in exactly two of the propositions. Okay, so like three components are there, A, B, and C. So if A and B are somehow related, B and C are somehow related. So then how A and C are related? So something like that. uh, yeah, so that is called this categorical syllogism. There is no particular difference. This is just a extension of that. Now, like if you see some example, like you can see, I will discuss in details, so don't worry. So example is, no heroes are cowards, some soldiers are cowards. So therefore the conclusion is that, so there here are three parts: hero, coward, and soldier. So then the conclusion is that therefore some soldiers are not heroes. So this is a very basic thing of syllogism. Now, a standard form of syllogism, that is the form in which a syllogism is said to be when its premises and conclusions are all standard form categorical propositions like A, E, I, O. So these I will come one by one and are arranged in standard order. Okay, so basically there are three parts: major premises, minor premises, and then coming to the conclusion part. So these three parts are there for this syllogism. Now, what are these things? I will just quickly say that major terms or major premises. Major term, first I will say that the term that occurs as the so first is subject and predicate. So this is I would have given later, which maybe. So there are two parts in this premise, like, right? Okay, one is subject, that like A, B, and C are there. So one is subject and one is predicate. So the major okay, so the subject, you understand, in a, if we go here, like, no heroes are cowards. So here we are describing basically heroes, and then some soldiers are cowards. So what will be subject? So one will be here the subject part, one will be this predicate part. Okay, so subject is the main part, the phenomena that we are describing, and predicate is the how we are describing that. So that is the case. Now, so what is the major term? The term that occurs as the predicate term of the conclusion in a standard form of categorical syllogism. Minor term, the term occurs in the conclusion subject term in a standard form of categorical syllogism. So these are just the terms I think you will understand when we'll discuss with lots of examples. Uh, the main thing is the major premises. In a standard form of categorical syllogism, the premises that contain the major term, okay, that you understood, and the minor premises is just the opposite. The standard for the premises that contains the minor term. So this is very important. In a standard form of syllogism, the major premises is always stated first, the minor premises second, and conclusion will come last. So these are the what will I say? These are the rule book, or how these things are described. The syllogism. So major premise will come first, then the minor, and then it will conclude. So conclusion will come always at the last. Now moving forward. So now we will learn how to. Let me do one thing. Okay. So how to use Venn diagrams for solving this kind of problems? Okay. So Venn diagram, this is named after some theoretician. So the Venn diagram is nothing but the use of different circles for solving or connecting different premises to come to a solid conclusion of that, right? uh, So first we'll see the simple ones where using two circles how these are related, and from using that how we can conclude, and then we'll come to using for these three circles. So the rule is simple. The circle A contains A things, circle B contains B things, and circle C contains C things. So these are the usual things that is said there. Now, if you look at here, the rules how to use them. So draw overlapping circles first. So that is the main funda, that we'll draw the circles first. Then we'll describe. So then first draw all and no premises by shading. So how to do that? That will come. Then draw some premises by putting cross in some unshaded area. When cross in unshaded areas, this argument is invalid. So this, I mean, this we don't need to bother right now. And if you must draw the conclusion, the argument is valid, otherwise it's invalid. So these are the things that will lead you to a conclusion basically. Now the rules I'm coming. So rules are, uh, so let's say there are three circles A, B, and C, as we have seen earlier. I think it will be better to copy that. At least you can see something. Okay, so the central area where all three, here you can see three circles are there. So A contains A elements, B contains B elements, and C contains C elements, or you can say that premise A, B, and C. So the central area, that is this part. So this part, the central area where all the circles overlap, contains whatever has all three features. So this is the common for three of the elements, okay, or three of the premises. Second is the middle areas contain whatever has, so the middle areas contain whatever has only two features. For example, A, B, but not C. So now, so what are those parts? Those parts are basically, so those parts are basically this part, this part. So this was the major part, and this part. Okay, so that is the second one. So so here you can see A and B are there, but not C. Yeah. So here A and B are there at this uh, colliding position, or this colliding area. Here A and C are there, this area, and here you can see B and C are there, not A. So these are the three areas. Other is three outer areas contain whatever has only one feature. So what are those? Okay. So so let's say these areas, like this area is only B. There is nothing common. This is only A, nothing common, and this is only C, nothing common. Okay. So this is the third point. Now each of the seven areas can be empty or non-empty. Like total seven areas are there, right? One, two, three, four, five, six, and this is a common for all three. So can be empty or non-empty. Each of the seven areas can be empty or non-empty. Now we put a cross in the areas known to contain at least one entity. I mean, cross means there is something is common in between them. An area without either shading or an cross is unspecified. So when there is shading, it means there is no common portion is there. Okay, shading means no common shading or Darkening means no common person is there, and cross means some common person is there, and nothing is there means that portion is unspecified. So it could be either empty or non-empty based upon the premises. Okay, so these are the basic rules of drawing these circles for solving problems in Venn diagram. Okay, now first I am coming then an universal affirmative proposition. Okay, so here are first A, E, I, and O. They are the first four premises where we will use only two circles. Okay. So first one is A proposition. What is A proposition? A proposition is all A is B. So that is the A proposition. Shaded areas of A that are not B. So this contain A, this contain B. So this is the common area, and so this is so all A is B means, excuse me. So whatever A is there, that is included B. So this is the areas, shaded areas are not in B. So this is the common area that includes B. So like an example, all animals are beautiful. So everything in the animal circle is in the beautiful circle. Okay, so if this is animal, A for animal and B for beautiful, so everything in the animal circle will be in the beautiful circle. Okay, so that is the thing. So the diagram which asserts that here it is, I mean, I have taken it from two different sources. So in one case it is taken as A and B, and other case this is S and P. And S and P, so A stands for subject case and P stands for predicate case, as I have told earlier. So I'll discuss in this way only. In both the examples are there. So the diagram which asserts that all S is P shows that portion of S which is outside of P shaded out, indicating that there are no members of S that are not members of P. So this area where is no member of S, that is member of P. Okay. So now, one example, like one with one particular example, I mean, only the dialogues are changing. Okay, so that will come. That will be easier for you to understand. Like, so here is the first example. All politicians are liars. Okay, don't take it in any other way. So these are just examples for the sake of our understanding. So in this, we assert that the whole of one class is included in or contained in another class. All politicians are liars is an example. It asserts that every member of one class or politicians. So the class is politicians and is the member of another class, that is liar. So here subject class is this politician and the predicate class is the liar. So all politicians are liar. In that way, it is coming in this A proposition. So this was the first. So this is, if you notice, so this is affirmative, like this is confirming something that A, all A is B. So this is also called in some way, this is affirmative proposition. So that is universal affirmative proposition, that I will come also. Now coming to the next, sorry, before coming, so another example is given. Okay, so like this all A's, so this is with S and P. If you look at here, all bananas are fruits. So this is bananas and these are fruits. Okay, so when a term refers to every member of a class, we say that the term is distributed. So this is another interesting thing. What is distribution? So in a proposition, so A is the proposition. The subject term is always distributed. So what is the subject term here? So what is the premises? Premises is all bananas are fruits. So yeah, when a term refers to every member of the class, we say that the term is distributed. So all bananas. So here is the banana is the subject, but a preposition does not refer to every member of the predicate class. So all members, all bananas are fruits. The subject is banana, and fruit is the predicate class here. So here. It is describing that all the bananas are included in the category of fruit. It means they are banana is distributed, but not fruit, right? So it is not confirming anything about the predicate class or the fruit, but it is confirming about banana. So this example does not assert all fruits are banana. So the opposite is not true. So then that is the case. So in this way, this proposition is coming under universal proposition of. Okay. So this is the first proposition gone. Now coming to the next one, that is the E proposition. So it is no A is B. So this is kind of a negative proposition. Okay, this is not confirming anything. So no, it is confirming, but in the negative sense. So no A is B. So no animals are beautiful like A and B. So said wherever A and B overlap. So this is the overlapping portion. So no A is B in this position. Okay. So earlier it was this portion was shaded, so this was common. Now here this is the uncommon. No A is B, and so this is the rest part anyway. So if we look at here, this kind of proposition denies the relation of inclusion between the two terms and denies its universality. It tells us that no members of A are members of B. Propositions in the standard form are called universal negative proposition. Earlier was the positive one. They are also called the E proposition. So if we look at here in the same example, no politicians are liar. So a proportion in which it is denied. Uh, so if you look at here, so two class again, no politician and liar. So no politicians are liar. So it is the subject class and it is the predicate class. So it asserts that the subject class is wholly excluded from the predicate class B. Okay. No politician is a liar. So this class is completely excluded from the liar, the predicate class. So this is now if you look at in the similar way, so no bananas are fruits. The same way, right? So no common portion is there. So subject class is banana and predicate class is fruit. So banana is completely excluded from the predicate class of fruit. So that is the thing. Now the third thing, that is the I proposition. I is a particular affirmative proposition. So here's the proposition is some or the premises is some A is B. So some A is B means I earlier said that if there is some term, then this cross term will come. Okay. So X is unshaded area where A and B overlaps. Some animals are beautiful. Something in the animal circle is in the beautiful circle. Okay. Uh, in this way, some politicians are liar. If we look at here, so then the subject class is this politician and the predicate class is again liar. So it does not affirm this that these are politicians universal, that it is not talking about the entire politician group but talking about some of the group. Only some particular politicians are said to be liars. So the proposition does not affirm or deny anything. So it does not, so it means that they are saying that some politicians are liar. So it does not mean that all politicians are not liar. Okay, so that is the tricky part. Some politicians are liar. It makes no pronouncements that about the entire class. Nor does it say that some politicians are not liars. Although in some contexts it may be taken to suggest that. The literal and exact interpretation of these propositions is the assertion that the class of politicians are the class and the class of liars have some members in common, but they are not entirely collapsing or colliding. Okay, that is why we understand that these standard from propositions to mean. Okay, now, if we look at in the same example, some bananas are fruits. So you understand, right? Some bananas there are there and some fruits are there. So it means some banana is coming under the category or the predicate plus fruit, but it does not mean that all bananas are not fruit, but all bananas are fruit. It is not at all confirming anything. but it is saying that but there are some common portions are there between this subject class and the predicate class. Now, and the last one, that is the O proposition. O is this particular negative proposition. So sum A is not B. Again, this is negative. So some A is not B means some common portions are there and most and some are not common. It is confirming that some A is not B. It does not refer to, so some politicians are not liars. It does not refer to politicians universally, but only to some members of these politicians who are not liars. So it is not saying that. So unlike the third example, so however it does not affirm that the inclusion of some members of the first class into the second class, these are precisely what is denied. So it is denied that some politicians are liar, but it is not saying the opposite one, right? So in this way, this is also a negative proposition. So from here we can see there are total of four: A, I, O, and E, and between them two are positive, which is confirming, and two are negative. Uh, the same example is basically, so some bananas are not fruits. It means, so if we pronounce from here, that it will be better to understand. So the word "some" again tells us that this proposition is not about all members of the class of bananas. The subject term is therefore not distributed. Again, the distribution term. So subject term is the banana. It is not distributed means if we talk entirely about the class, or if we about the if we talk about the entire or describe the entire class of thing. If that is not the case, then it is not distributed, because we are told that in proposition that some bananas are not fruits. We're not we are told something about the entire predicate class. So here the predicate class, that is the fruits, that is entirely distributed. Namely, the entire class of fruits does not have one subject bananas among them. So in O proposition, the predicate term is distributed, but the subject term is not distributed. If we go back here, in the I proposition also neither. So in the I proposition, what was the proposition? That some bananas are fruits. So here not some bananas are fruits. So here none of them are totally distributed. In I proposition, neither subject nor predicate, because you can understand that we're talking about some banana, not the entire banana class, again not the entire fruit class. But if we look at here, it's confirming that some bananas are not fruits. So we are describing in the entire fruit category or the predicate class. So that's why here predicate class is distributed, whereas not the subject class. So uh, now this is to summarize. Anybody wanted to say anything? So to summarize the thing, here are the four categories: A, E, I, O, and so the propositions are all SSP. This is the universal affirmative, like an example, lawyers are wealthy people. Now the second one is no SSP, that is universal negative. This is universal negative, so no criminals are good citizens. Third one is particular affirmative, so it means this is positive one. So that is I, some chemicals are poisonous, and O is the particular negative, so some insects are not pests. So excuse me. So based upon these premises, we can solve different problems. Okay. Now, uh, so now the thing is that I'm coming to some different terms that is related to this question. That is quality, quantity, and distribution. I don't think these were all described in the class, but I thought that this might be important or interesting to know. I'm just saying, and not in detail, but in very layered way, so that at least you can know about something about this. Then you can elaborate also from some other sources as well. So, what is quality term? So, quality An attribute to every categorical proposition is determined by whether the proposition affirms or denies the class inclusion. So thus, every categorical proposition is either universal in quality or particular in quality. So if you noticed earlier, so these two are universal, while we are talking about all and no. So these are universal. We are talking about the entire class. And when this sum term is coming, then these are becoming particular. So that is particular class. So A and I come from the Latin word aff- affirmo. Means I affirm. That's why these two are uh, affirmative class, or if you sorry, if you go back here, universal affirmative class. This is called. And next, so these are affirmative in quality. And next one, this E and O, these are coming from this Latin word nego. So it means I deny. So these are coming from this denial term. So that's why this particularly negative in quality. So so these are the basic thing of quality. Next, coming to quantity. So it attributes of every categorical proposition is determined by whether the proposition refers to all members or only some members. Okay. So the class. So thus every categorical proposition is either universal in quantity or particular in quantity. So if the proposition refers to all members, so it is universal. If some members, then this is particular. So A proposition, all SSP, and E, no SSP, both are universal in quantity. And in the similar way, I and O, both are particular in quantity. This is quantity. Now coming to distribution. So what is distribution? So an attribute that describes the relationship between a categorical proposition of and each one of its terms, indicating whether or not the proposition makes a statement about every member of the class. So if I pronounce from here that in the A proposition, like this is an example is given, all senators are citizens. So in this proposition, this is universal affirmative. The subject term is distributed, but the predicate term is undistributed. So this is basically the same thing that I told earlier. So yeah. So so this proposition, it means that this is universal affirmative, and it means that this is here the subject term is distributed, not the and the predicate term is undistributed. In the second case, no athletes are vegetarians. So this is the E proposition. The subject term athlete is distributed because no is talking about the entire class of athletes, no athlete. So because the whole class of athletes is said to be excluded from the class of vegetarians. So unlike an A proposition, therefore an E proposition refers to all members of the class designated by its predicate term, and therefore also distributes its predicate term. So E proposition distributes both their subject and their predicate terms, right? No athletes are vegetarians. So here, both are distributed. Coming to the third one, I proposition, some soldiers are cowards. So here talking about some soldiers, so it is not talking about the entire class of soldiers. It means this is the subject, although soldier is the subject class here, but then soldier is not, the subject class is not entirely distributed. So what is the case? It says nothing about each and every soldier and nothing about each and every coward. So neither it is talking about interclass of soldier, that is the subject, or not about the interclass of the cowards, that is the predicate. So here then none of the term subject and predicate is distributed. So here in the E proposition, both are, here one subject was distributed, here or subject and predicate both are distributed. Here neither subject nor predicate is distributed, and finally in the O proposition, some horses are not so breeds. So true breed means the pure blood or pure breed kind of thing. So nothing is said about all horses. So in O proposition is not saying about the entire horse class, but it is saying about the entire trovate class, right? So the subject term is not distributed, but the predicate term is distributed. So if we look at, or if we summarize, so if we summarize here, so yeah, the column and row you can see. So this is the subject term distributed where A and E are there, and here, so these rows are talking about subject term distributed and undistributed, and these columns are talking about or encountering the predicate term undistributed and distributed. So if whichever box you check, it will depend, depending upon that it will be distributed and undistributed will be decided. So here is the A term, all A's is P, the subject and predicate. Subject is distributed, but predicate is undistributed. For the E term, subject is uh, subject is not subject is distributed and predicate is also distributed. The third section, well, the third section is so the second row, that is the I, that is some A's is P, that is subject is undistributed, but predicate is also undistributed, and the last one is where subject is undistributed, but subject is, sorry, here I made a mistakes. Subject is undistributed and predicate is undistributed, but in the O term, yes, subject is undistributed and predicate is distributed. So these are the, if we talk about this distribution thing, that is the summarization of all. So now till now we know the thing that how to draw these diagrams using two different circles for solving these problems, and then we talked about this major premises, minor premises, and then we described about quality, quantity, and the distribution about different premises, and coming to a conclusion based upon those, and how the subject class and predicate class is distributed and undistributed in different premises, that we also described or understood from this discussion. Now there are another rule, or I would say like another relationships are there between these two things. So for that we need to know few more things, that is opposition. So that is called basically the traditional square of opposition. So the first one is the opposition, and some terms we need to know. The first one is the opposition. So that is the logical relation and that exists contradictories between two contraries, or in general between any two categorical propositions. So what is contradictories and contrary, that will come. So opposition means that this is uh, any logical relationship between two propositions, that is basically the oh, so then Then coming to contradictory, so two propositions are so related that one is the denial or negative of the other, or the traditional square will come. So on the traditional square of opposition, the two pairs of contradictories are indicated by the diagonal of the square. Like A and E propositions are the contradictories of O and I. So respectively. A and O propositions are contradictory. So you can understand from here. So okay, right. So two are affirmative and two are deny or negative. A and E is affirmative and O and I are negative. So those are contradictories. What are contraries? Two propositions are so related that they cannot both be true, although they both may be false. Like an A proposition, all poets are dreamers, and its corresponding E proposition, no poets are dreamers, cannot both be true, but they can both be false. Like all poets are dreamers can be false, and no poets are dreamers can also be false. But at the same time they both cannot be true. So these are the contraries between A and E. And then coming to subcontraries, two propositions are so related that they cannot both be false, like I and O, although they both may be true. So in particular proposition like I and O, so I proposition says that some diamonds are precious stones, and O says that some diamonds are not precious stones. So both might be true, that some diamonds are precious and that some diamonds are not precious, but both cannot be false. But could be true, but they could not both be false, and therefore must be regarded as subcontraries. Okay, so these are just the textbook definition that you need to know. Then, so this is the traditional square of opposition. So if you look at here, so this rectangular kind of thing, we are calling this traditional square of opposition. So the four corners are holding by these four propositions like A, E, I, and O. Here this is A is all S is B. So then again some terms are coming like superaltern and subaltern. So did I include all this? No, I think I didn't include because you don't need to know. I just included this image to understand that how these premises or these propositions are related in through this diagram. Okay, so contradictions, A and E are affirmative, so or positive. That is, so here the thing is both subject is distributed and not the predicate. In the E, both are distributed. Again, coming to O and I, so some is I is some S is B, nothing is distributed, and O is some S is not B. So again, the predicate is distributed, not the subject. So A and O are exactly contradictories. I and E are exactly contradictories, and so A and E are contraries, as you understood that how these are contraries. So how here these are contraries. So contraries are they can both cannot be true, but both can be false. So that's why they are A and E are contrary, and I and word subcontrary, because both can be true, but both cannot be false. Right. So that's why these are subcontrary. So that's how these are related. So these diagonal things are to depict that how this relationship will help you to understand to logically solve some problem, or this will be very much easier for you to understand or solve any kind of problem that will encounter in the upcoming section, right? So now, to summarize these things, a number of very useful intermediate inferences may be readily drawn from this information embedded in this traditional square of opposition. So I have told already these things, but still I'll say pronounce like if an A proposition is the premise, then according to the square of opposition, one can validly infer that the corresponding O proposition is false. So it will be better, I think, if I again copy it. Sorry. So it's enough if you can see here. So this you can see now. So if A proposition is the premise, if this is the premise that it is given that all S is P, then one can verily infer that the corresponding O proposition, it is the exact opposition, is false. So that's why they are contradictories. Again, uh, again, so if an A proposition is the premise, then the corresponding I proposition is true. So because they are subalternation, so you don't need to know, because if all S is P and some S is P, so then if A is true, then I must be true. If all S is P, then some S must be P. Okay. If an I proposition is premise, then its corresponding E proposition, which it contradicts, must be false. If some S is P, then some S is not P. So that will be then false, because it cannot we cannot confirm from here if which some S are P, then we cannot conclude we cannot say from it is if it is said that some S is P from the I proposition, then we cannot confirm from there that which A's are P. Then from there we cannot infer to the thing that some A's are is not P, right? Which A's are not P, then that will not be not be able to say from that premises. So then if I is true, then O is uh, no S is P. No S is P. So is that is false. So now this will help you out for this for solving the sections. Now now we're coming to how three premises are related. Now if two premises are given, like if you see from here, all H is D. So if you look at clearly here, so this is H and this is D. So all H is D means, so if you see that this portion is excluded, so only this overlapping portion of H, so that is all H that contains D. So all H is D, no F is D. Again, no F is D means if this is F and this is D. So this is the overlapping portion, and so it means so this portion means nothing of this is D. So it means nothing of F is D. So concluding here that no H is F. So how to solve then? So we draw all H is D by shading areas of H that are not in D. This we have done. Then we draw no F is D by shading the where F and D overlap. So this is the portion. Here we have automatically drawn the conclusion that no H is F. So we have shaded where H and F overlap. Okay, so if we now these two are so these two are related. These two are related. We're trying to draw some conclusion based upon on the relationship of H and F. So if you look closely, then you can see that this between H and F, this portion is shaded. So it means no H is F, right? So because that is already shaded, so it means between H and F. So that's why uh, no H is no H contains A. So this is the first point. So it means, so now in the second one, so the argument is valid. So the first argument was valid, so that we have described. Now the coming to the second one again. Now so first one was the affirmative one. If you follow, all H is D, no F is D. So all H is D means A premises were there, and no F is D means E premises were there. Sorry, not E. What will it be? O premises. Yes, E premises are there. I'm confused. Now, then it's coming. There is no H is D. Means if you look at here, H and D. So no H is D means, so we'll overlap the overlapping portion. We will blacken it out, or we'll cross it. Sorry, we'll shade it out. So no H is D. Now no F is D. H and D, now D and F. So again, this is also darkened. So no F is D. Now what is the relation? Then H and F. No, then no H is F, because already between H and F portions are darkened. So, but if you look at here, that we can see some portions are, so we draw no F and D by shading and where F and D overlap. Here we have not automatically drawn the conclusion that no H is F. We have not shaded all the areas where H and F overlap. If you see that all the portion that H and F is overlapping is not black automatically. So that's why we cannot conclude from here that all the no H is F. So it means that no H is F is invalid. Okay. Now coming to another one. Uh, here we will use the sum term. So no D is F. Now if you look, no, so now we're talking between D and F. So no D is F means, so then we will blacken out this portion because no D is F. No portion of D contains F. Anybody unmuted want to say something? Then please mute. Uh, then some H is F. So first is D and A, then H and F. Some H is F means, so some portion of H contains F. So there will be a cross we have discussed earlier. So some H will be F. So what we see then between H and D. So this is H and D. So if you look at here between H and D, what is coming? This portion is coming. So between H and D. So but then we have automatically drawn the conclusion that some H is not D, right? So if we so then this conclusion that some H is not D because some portion is shaded and some portions are not shaded. So it means some H is not D. So that will be and then this argument is valid. We are coming to a valid conclusion. Coming to the next one, again some invalid one. So no D is F. So how to draw? No D is F between D and F. So obviously some portion will be shaded. So no portion of D will be included in the F class. Then some H is not D. Some H is not D. So between H and D we will draw, and then we will cross out the non-overlap portion because some H is not D. So then what is resting? That if this is cross, this portion is also cross. You can understand from the drawing. So we draw that some H is not D by putting cross in both the unshaded areas. So unshaded areas. So H is so then what is the case between H and F? So some portions are shaded and some portions are crossed. So some H is F. So if some H has to F, then it has to become the rest of the portion should be darkened. So that is not the case here. Or sorry, so the rest of the portion should be crossed, but that is not the case here. So between this H and F, if you properly look, some portion is darkened and some portion is crossed. So it does not tell us that some H is F. Clear? So that's why the argument that some note is, I mean, so then the conclusion is that is invalid. This is not concluding to the right one. Now, so again the next one I'm coming. So here no D is F. Some H is not D. So so the thing is that it will your we are valid and invalid saying because that is not leading to a valid conclusion. But the thing is that we are reaching to the conclusion based upon these diagrams only. I mean, there is no hesitation that we are reaching to the conclusion based upon these premises. But that is valid or invalid, that is different thing, right? So now again the next one. So no D is F. Now between D and F, if you look, so no D is F means some shaded area will be there, obviously. So no D is F. It means I'll say that this is shaded area. Then coming to the some H is not D. Between H and D, some H is not D means that the non-overlapping area will be crossed out. So you understand now. So this is the crossing position. So that this, so it is this harm area is not D, and this is talking about some no D is F. Now what is the then relation, then H and F? If you see, some H is F. So some portion is shaded and some portion is crossed. So now as some portion is crossed, the conclusion that some H is F is all is valid then, because whenever there is this cross term, then it will say that some portions are common between these two premises, like H and F. If some portion is common, then this cross term will come, because what is happening in this earlier case, here the conclusion is that some H is F, but that was not the case here. But if you look at here, that some as some cross sections between these two are there, that's why some H is F, it's logical, although uh, that is logical. Okay, right. Now so when we erase this x or the cross term, that draws the conclusion that some h is f. So then we have drawn the premises without drawing the conclusion. So that's why it is we are saying it invalid. I think you understood that. Right. So in this way, if we use these Venn diagrams, we can come to different conclusions, or we can come to conclusions where we can, using these tools, we can clearly or easily understand or easily come to a conclusion. That will be valid or invalid. That is separate thing. But we can, based using these things, we can come to some conclusion. So I think the in the last week that we are discussing about the problem that was given in the assignment 2, that will be now easier to understand. So now one by one we'll discuss about this assignment 2. Now I think it will be easier for you. Okay, so yeah, please. Okay, okay. Yeah, so these are different notations used by, I mean, different techniques only. Okay, so what is taught in the class, that is also true, because that is saying that all A is B. It means that you are saying that all entire A class is included into the B class, right? Now, as we have discussed here, yeah. So yeah. So but if we look at here, so all A is B. B means whatever area is overlapping, that is the all A, and the rest portion is, that is, I mean, that is not there. So I mean, that is entirely included. So we are talking about, so how would how would I say that? So any A that is colliding with B, I mean, any portion of A that is included in B. So but anything that is not colliding with B, that is not A. In that way I can say, right? So if we are drawing, this is just a notation. Again, I am saying, as sir described there, like two circles, one is included in the other. So you can solve the problems in that way or in this way also. So here it means that these two circle, so all A is B means anything that is not within B, that is not A, right? So that's why this portion is blackened out. So anything that is not included in B, that is not A. So that is the conclusion. So in that way, you can, I think you can correlate with that thing also. Clear? Yeah. Yeah. Uh, mhm. So all women are human. So then let's say A is human and then B is so A is women and B is human. Okay, then all A is human means so this colliding portion. So that will be so I mean if you understand like that. So so anything I mean that the race portion will be black and red. So then it means there is nothing. So there means in that portion um, so how would I say, so all A is B, so it means that this portion is not A. So blackened portion is then uh, anything that is not included in B, then that is not A. So all human women are human. If you I might be wrong, although I'm trying to yeah, but yeah, yeah, very confusing. Yeah, I mean, but I think to solve those problems, I think this will also help, right? Because those kind of things are there that is described or that is there in the assignments also where you have seen. So that's why I have given this time, because I think that will help out. But as you said that all women are humans, if I correctly understand, then so this portion, then this woman, those are human. So entire woman class is included in the human. So anything is there. So these are not women. In that way, I can understand. Or although I'm saying again that these are just the notation to understand. So there's nothing hard and fast things are there, but this is also well accepted. So you can anything or any notation you feel easier for you, that you can use for solving the problems. Right? I think clear. It is clear, right? Yeah. Okay. So now I'm coming to the problems. Yeah. So this was the first problem. I think we had a discussion last week. So this is although from related from the last week's discussion. Uh, so the premises is it is given that if copper is dipped in vinegar, then copper turns green. So the answer will be, so the four answers are there. So you are sure, you're clear that if these rectangular boxes are there, then the multiple answers will be correct. And if spheres are there, there's a simple one is there. So the first one is if copper is not dipped in vinegar, then the copper does not turn green. If copper turn green, then it must have been dipped in vinegar. Now, first one is if copper is not dipped in vinegar, then copper does not turn green. Uh, it is said that if copper is dipped in vinegar, then copper turns green. But it is not said that there is no other options for copper to becoming to turning to green. Okay, it is that is not clear. But it is said that if it's dipped in vinegar, then it will turn green. So in this way, this first option will be excluded. So if it is not dipped in vinegar, then it doesn't turn green. Second one, if copper turned green, then it must have been dipped in vinegar. Again, this said the same thing in the opposite way. If turned green, then it must have been dipped in. That is not also the case. So because there can be other ways or of the copper to become green. So then this is also excluded. Third one, if copper did not turn green, then copper was not dipped in vinegar. So if it did not turn green, then it was not dipped in vinegar. So this is now correct, right? So if you look at this modus tollens and modus ponens test, so modus tollens, what does it say? That if A, then B. If uh, so if not B, then then not A. It's not B means if B is not true, then A is also not true. And modus ponens said if A, then B, and if A is true, then B is also true. So then the final one, if copper is dipped in vinegar, then copper must turn green. So this is also correct, if you see, and this is also correct. So these are the answer. Like, so these are basically following these two things: modus tollens and modus ponens. So this is clear. I think last time I think some of you had doubt about this question. I think it is clear now, right? If you yeah, so if you apply the logic of modus tollens and modus ponens, so this will be pretty much clear. Now coming to the second one, so the following statements are giving. So statement one, if the concentration of CFC or chlorofluorocarbon in the air exceeds a threshold, there will be a hole in the ozone layer. Statement 2, if there is a hole in the ozone layer, a larger amount of ultraviolet radiation will reach Earth's surface. And the third one, ultraviolet radiation causes cancer. Now the premises are given. What conclusion can you draw using valid logic if following premises are given? So what is the premises? There is an increase in CFC in the air beyond the threshold, right? So it means now you can understand that multiple options will be correct. So if it is saying that if there is an increase in the CFC in the air beyond the threshold, so if there is an increase in the CFC beyond the threshold, then there will be a hole in the ozone layer. So there is a hole in the ozone layer. So then this will be correct. Death rate is increased. Again, here in the given statements, nothing about death has been given, so we cannot say that why the death rate is increased. It can be because of cancer, but again it cannot be also. Then we're not sure about this, so then this is crossed. Third one is there is a very small amount of UV radiation in Earth's surface. So that is, it is already said there is an increase in the CFC in the air beyond the threshold. And so then this is also crossed. And the fourth one is the incidence of cancer is increased. So that will be again correct, right? So if we look at the answer, so there is a hole in the ozone layer and the incidence of cancer is increased. So in this way, this is now sorted out that we can, if you put the logic properly, then we can understand. Now coming to the next one, this is clear, right? Anyone has any doubt? Yeah, okay, thanks. So now the third one, third one is same thing is given. The statements are same now. If CFC increases, there is increase, then there will be hole in the ozone layer. If there is a hole in the ozone layer, then there will be increase in the UV radiation on Earth's surface, and if there is increase in the Earth's surface UV radiation, that will cause cancer, increase in the cancer. Okay, now, now the premises is given. A statistical survey showed that the incidence of cancer has increased. So it means incidence of cancer has increased. Now, what are the conclusions giving? So now you can understand that only one will be correct from here. The first one, that there is an increase in CFC in the air beyond the threshold. Now the premises is given the incidence of cancer has increased. Now the cause of cancer can be other any other thing than that of this UV radiation, because it is not said that cancer is happening only for this UV radiation. So then first one is again not correct. Second one, there is a hole in the ozone layer. Following the same trend, we cannot say that whether there is a hole in the ozone layer or not. And the third one, there is a very large amount of UV radiation in the Earth's surface. That also we cannot say, because since so the what does modus tollens states tollens says that if modus tollens says that if A then B, if not B then that is not A also. So then, if not B, then not A. So since it is not B, so neither of the consequent backward statements will be correct. So in this way, none of them will be correct. So none of the above, as I had some doubt regarding this, so none of these is the answer. Uh, Clear, right? I think it is clear now. If anyone is responding, because uh, if I think because the logic is simple that if you so if you look at here, so if you just go back, so the final effect is the cause of cancer. The subsequent cause of that is UV radiation. Subsequent cause of that is ozone hole, and subsequent cause of that is increase in the CFC, increase of CFC in the air. So since this is not happening and this is not defined, because cancer can also happen from other sources, so then subsequent reason is invalid, then that subsequent reason is invalid, and in this way all are invalid. So then none of these are the answer. So then this will be the answer. Now coming to the last part of this, that is again the statements are same. Here the premises is a statistical survey showed that the incidence of cancer has not increased, right? Oh, sorry, the last one is the modus ponens. So this will be the modus tollens, right? The incidence of cancer has not increased. So cancer is now B. So if not B, then not. So there is an increase in the CFC in the air beyond the threshold. There is no hole in the ozone layer. There is very high amount of UV radius in the Earth's surface, or none of the above. So what will happen if not B? So then not A. So now can anyone can say what will be the answer with logic? You're clear about the last one, right? Then I think this is easier. Anyone can just say. Okay, it seems no one is interested. So, yeah, it's simple, right? So, but the answer is there is no hole in the ozone layer. So, can you explain why is that? So that was the accepted answer, right? Mhm. Yeah, no incidence of cancer. Says no incidence of cancer has not increased. So then, how it leads to this answer? There's no hole in the ozone layer. If not B, then not A. Then yes, yeah, in CFC, yeah, yeah, yeah. But I'm saying that so the answer is given. There is no hole in the ozone layer. Why that is given? I'm anyone else? So I think in that way it is correct, right? So if you just simply put the modus tollens, then it will lead you to the answer. So anybody has any doubt? Like, what ma'am has said that is true. So anybody has any doubt? So okay. If not, then we'll move forward. Okay, thanks. So if not, then we'll move forward. The next question, where I think we can use. Oh, okay. Another thing is left of this series. Okay, that one is the what conclusion can you? So the statements are same. Now the premise is a measurement shows that amount of UV radiation reaching Earth's surface has increased. So now, what will be the consequences? Or what will be the conclusion? Anyone else? Let's try. I think it will be easier. Okay, if not, then so what is given that first one is given that the incidence of cancer has increased. So the statement is the premises is a measurement shows that the amount of UV radiation reaching Earth's surface has increased. So, if UV radiation is increased, then then incidence of cancer has increased. There is a hole in the ozone layer. Uh, there is increase in the CFC in the air beyond the station, and all of the above. So, if you look at the answer, the incidence of cancer has increased because so that is only the direct consequence of the UV radiation. So, once UV radiation increases, it causes the cancer. So that's why it is right. So it will be simple as the modus ponens. If A, then B. So if A is true, then B is true. Like if if UV radiation is increasing, then it is causing cancer. So now if you are getting that this cancer is increasing, so it means UV radiation is increasing, or the opposite way, other way around. Like if the incidence of UV radiation is increasing, the cancer is will also increase. But then we cannot talk about or cannot comment about the others. Like there is a hole in the ozone layer because then. That can be caused from some other sources as well. There is an increase in the CFC. So these two are then crossed out. So in this way, we can negate one by one using this modus tollens and modus ponens, and we can come to a conclusion. So these are the four tricky questions used for using applying these two methods. Now coming to application of this one, right? Okay, so sorry, I didn't make it like that. So the here is the question. The following premises are given. Some particles have half integer spin, and no particle with half integer spin is a boson. So these are the we're talking about some boson particles, and half integer we're talking about the spin. So so now the some particles have some particle have half integer spin means if we call it some h is f, so then between h and f some common will be there, so then that will be crossed, and no particle with half integer spin is boson. Then if we say h and d is boson, and this is so sorry, some particles have half integer spin means h and f. So h is the half integer spin and f is the boson. Yeah. Okay. Okay. So here the conclusion that is the premises that is given, the statements being same, that a measurement showed that the amount of UV radiation reaching the Earth's surface has increased. So if the what does modus ponens say, that if A then B, then if A, then if A is true, then B will be true, right? So here it is said that measurement of UV radiation is increasing. So now if UV radiation is increasing, then that will cause an increase in the cancer rate. So the incidence of cancer will also increase. So that is the directly related. Now the second one is there is a hole in the ozone layer because we cannot. So it is said that if A is B, then but if A is true, then B is true. But it is not said that if A is not true, then B will also be not true. Or if it rather the opposite, if B is not true, if A is also not true, or A is true. We cannot comment about on that. We cannot go back. We cannot use. Yeah. Okay. Yes. Yes. Okay. Yeah. Thanks. Now, okay. So as we're discussing here, so Uh, some particles have half integer spin, so H and F. So that will be crossed A, and no particle has half integer spin in boson. So what conclusion then can we draw from here? So one will be crossed out, and in other case that will be shaded out. So then the conclusion will be, if you look here, this is the same thing. Some H is F and no D is F. So F is the half integer spin. So this is the F. So if we correlate with H and F, so this is some particle, and this is a half integer spin, and then again no particle with half integer spin is boson. So this is boson, this is a half integer spin. So these are shaded. So now what will be the conclusion? As it will be the same. So there are some particles which are not bosons, as we derived from this also that some H is not D. Okay, so because some portion is crossed and some portion is blackened out, so we can conclude that some H is not D. So that will be the correct answer. Or rather, some there are some particles that are not bosons. Next is coming the following premises. This all whales are mammals and some mammals are carnivorous. Then how do we use the logic? So all whales are mammals and some mammals are carnivorous. So then all and some we have to use. So can you please try to solve it on your own? I think based upon the discussion it will be easier. Just take your time. Just try to solve. Yeah. No, in case of some, so the overlapping portion will be designated with a cross. So it means that some of the so if I go back quickly, yeah. So yeah. So if you look at here, then some H is F, right? Some H is F means between H and F. So if you look at this, their overlapping portion, there is a cross. So it cross means sum of H is F. So it does not talk about the rest of the H. So it can be of F, it cannot be of F, but at least sum of H will be F. Then this portion is crossed, and also so now it's clear. And this blackened means that is excluded, that is no D is F. So no D is F means this portion is totally excluded with so, yeah, like that. Yeah, so the problem was all whales are mammals and all some mammals are carnivorous. So if we use some logic, sorry, yes please. Okay. Okay, no. So like I can draw from here if you sorry, to erase. Where is there? So if we draw, let's say one. Pardon me for my this bad drawing. So let's say these three are there. So let's say this is well, this is mammal, and these are carnivores. Okay, so then so it is saying that all whales are mammals. So then between whales and mammals, so there is all whales are mammals means so what will be the case then? So this will happen this way that anything that is whale that will be mammal. So apart, apart from this overlapping area with mammals, other portion will be shaded. This portion will be totally shaded out. So then this is the case first one, first relation. Second one is some mammals are carnivorous. So now the mammals and carnivorous. So some mammals are carnivorous means there will be a common portion, right? So then what will be the conclusion between whales and carnivorous? So if you look at here that so just look at the overlapping zone between whales and carnivores. So if you can see there is some cross W and C. So can you repeat? I just so if you look at earlier one, so yeah, so some H is F. So some H is F means if you look at here, then some portion that is overlapping that will be crossed. If had it been said that some H is not F, like here, yeah, some H is not D, then the outside of the overlapping portion will be crossed, not the overlapping portion. Clear? When there is not, then the outside. When there is some, only some H is something that, then that is then the overlapping portion. So now, if you look at here, uh, look at this overlapping portion between W and C. So this is the cross section is there, and some shaded portion is there. So from the cross section, we can say that so all whales are mammals, some mammals are carnivorous, then all whales are carnivorous. That is anyway you can understand that is excluded. Now some whales are not carnivorous. Some carnivores are mammals and some mammals are whales. So what does this cross section say? That some whales are carnivorous. So that is correct. Some carnivores are mammals because earlier it was said that all whales are mammals and some mammals are carnivorous. Not all carnivores are mammals, right? So there is a cross between C and M. So if you look at, sorry, uh, sorry. So if you look at, yeah, okay, if you go to the answer, so some carnivores are mammals, and so did I make a mistake? Some whales are not carnivorous. Some whales are not carnivorous. Yeah, that is also wrong, right? Some whales are not carnivorous because since there is a cross, then we can say that some whales are carnivorous, but we cannot say that some whales are not carnivorous. Okay, then that will be crossed out. Clear, so this is very confusing. So so this is the overlapping portion, Now some portion is shaded and some portion is crossed. So from here we can say that some whales are not carnivore, that we cannot say because some shaded, some crossed portion is there. Then coming, some carnivores are mammals. Some carnivores are mammals. Since they are sharing this cross section, then that we can conclude that some carnivores are mammals. And final one, some mammals are whales. Some mammals are whales. Yes. So since one cross section is there, so then we can say also some mammals are whales. So in this way, this is also correct. But this is, I think it is clear why this is not included. Some whales are not carnivorous. That we cannot conclude because there is some cross section is there. So this cross section is leading us to saying that some carnivorous is whales, or some whales is carnivorous. But it is not leading us to that some whales are not carnivorous. Yeah. Okay. So in this way, this is sorted out. So uh, now coming to the next section, if anybody has any doubt, then we can discuss further. Okay, I hope it is clear for all. So then we're going moving forward to the further section. A true conclusion can be derived from false premises. First statement. Second statement is a false conclusion cannot be derived from true premises. And the last one is the conclusion is statement three is true. So then we have to come in conclusion about these statements, which is true and false. So we had a relationship earlier that you discussed, so that all the premises are false. All at least one of the premises is false. All the premises may or may not be true. At least one of the premises is true and none of the above. So first one is saying a true conclusion can be derived from false premises. That is correct, or it cannot be correct also. Like if you see the last year's discussion, from there you can easily understand that the option will be all of the premises may or may not be true. I'll not go in detail about that, about these premises. And so there we had discussed enough. So from there you can see that if we think logically and then see the relationship between them, then you can come to the conclusion that this will be the correct answer. Uh, Coming to the next one, so this is also easy one. Which of the following, according to Aristotle, is not a type of structure syllogistic argument may have? Every A is B, some A is B, no A is no B, and some A are not B. So the answer is no A is no B because we didn't talk about any such kind of premises, right? In our discussion section. Now coming to the last one, that is also a knowledge-based question. If you read, so when Edwin Hubble used Cepheid variables to find the distance to the Andromeda Galaxy, he was using which of the logic, like inductive logic, deductive logic, both inductive and deductive, and quantitative inductive logic. So if you read the story there, you will clearly understand that he was using inductive and deductive both logic. For some portions he was using inductive, and so for some portions he was using deductive. So I think you have all read about that story because that was discussed in the class, I think. So and from that we can conclude that inductive and deductive logic, because I'm not describing this because this is a knowledge based question. So in this way we can describe the questions. Actually, I saw some questions of earlier year or the previous year. So there, most of the questions are like uh, similar to this. And no new concept or question was there that I thought of discussing here. So that's why I didn't include any of them. So in this way, we have discussed the second assignment I hope all of you have now more or less understood the things and or how to sort out the things. This will be, I mean, the exam that will be helpful for you. Now, the assignment of the subsequent weeks has also come, third, fourth. So, what I have seen that in the third year, there is mostly history, but I don't know how we can or I can describe or that portions because there is mostly history part, right? So and mostly then there will be knowledge based part, no logical things is there, so nothing much is there about to describe about logical things, right? So I have to see how we can figure out of the next week. If I if I quickly go to the this section. Yeah, so third week is historical perspective and based upon their, I mean, only the historical thing. So if I describe the assignment there, so that will be pretty, I mean, there will be nothing to describe. I don't know what will describe. Uh, you can suggest also if you have any doubt in the assignment 3 as we have discussed, because in the if you look at here in the first and second week there are some things that we had to understand, so that's why those things are there. But is there anything in the week 3 that is that we should describe or we should discuss, because mostly these are knowledge based. So you can anyone can comment if anything is there. Then I'll think about preparing something for that. Yeah, yeah, that I can do. That actually I was thinking about, but then I was thought of hearing from you that you have any problems regarding this, because mostly these are you'll get from any standard books, or if you're following any books or any notes available. So this answer you will get, so nothing about these things to describe. But yeah, this logic things that I can surely this Venn diagram and all these logical things, that problem I can include. Sorry, proposition, application part. Yes, 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 absolutely. So yeah, that I will prepare then. I mean, there are numerous problems are there. I thought of including today, but then I thought of first discussing the second week assignment. Then, if you are interested, if you feel about discussing those things will be beneficial for you, then I can go forward. Uh, so third week assignment date is also over. That is submitted, and in the fourth week also that is the same thing. Like this historical perspectives are there. I think from the week 5 again something that we can describe or we can discuss, some hypothesis based things are there or measurement things are coming. So there again I can or we can come rather in picture and discuss about this solving problems. So then that will be easier for this week 3 and 4 we have to figure out. Then in the next week hopefully I'll prepare some problems, then we can solve it together. Maybe I'll give some time live, then you can try to solve within some time, let's say 5 minutes for or 2 3 minutes for a particular problem. So there will be some different level, easier and then harder I think. So then that will in that we will conduct the next week. I have to think about the subsequent week as well. From the fifth week, I think so. This is the third week is going on. So in the fourth week, we can discuss that thing about the problems. From the fifth week, it will be easier again, I think, because this logic-based things are coming. So then we can comment on that. So assignment of assignment of week 5 has also come. So yeah, yeah. Anybody else? Yeah. Yeah, yeah, sure. So PPT, I'll immediately actually there is a portal, there is a Excel sheet. So there after as soon as the today's class is over. So this entire video and the PPT is uploaded there. Now I think so that that folder is not shared with you, and Google Drive, I think that is shared with you, right? Yeah, so that is the link of this Google Drive. I think a mail has come, right? Okay, is it? Yes, yes. Yeah, so if you look at here, so yeah, so you can see, you'll click here. So yeah, this is the sheet I was talking about. So there you can see each week's link as well as the content. So and this is the folder content of the folder, and these links are, I mean, this drive is accessible to all. That's how it is made. So you can, from here you can access the, yeah, yeah. So so that is the plan. Then we will, next week we will discuss about some more problems. I don't know how can we'll able to cover 2 hour. 2 hour is actually pretty long. So but that is the norms they have given. Uh, for solving all these things, 2 hour is, I don't think that is required. We can, 1 hour is, I think, more than sufficient. But still, then this is beneficial in the way that we are discussing some additional things that is not discussed in the class, or some different technique that will be helpful for you as well. So then well, the next week we'll try to figure out some more problems, or try to solve some more problems. Then we'll see how it happens. If you have any doubts or problems, you can write back to us or NPTL as well. Uh, so I think we can close this session for now today, right? If anybody has any doubt, or otherwise I'll close. Okay then. Goodbye to all. I'll close. Right? Yeah, yeah. Bye. Yeah. Good night. Yeah. Thanks. Thanks. Bye.